Here we are going to demonstrate how to solve a pair of simultaneous linear equations using matrices. Okay, so here is our pair of simultaneous linear equations. Our x's are aligned, x on x, y on y, and constant on constant. So the step number one is to form a matrix equation. So let's do that. So therefore now we're going to make a 2 by 2 with the constants. So we see in a 2 and a 6 will form the first row, and the second row we'll use a 1 because if you don't see a coefficient, if the coefficient is blank, there's an invisible 1. So there's an invisible 1 in front of x. So 1 and 8 will form the second row. Now we have to make a column matrix with the letters with x and y. Equal, and then you have to make a column matrix with the constants. Here is our matrix equation. Now, step number 2 is to find the inverse of the 2 by 2 matrix. So we have to find the inverse of 2, 6, 1, and 8. So the inverse now of this 2 by 2 matrix is 1 over the determinant times the adjoint. The determinant is 2 times 8 minus 1 times 6. And the adjoint, you have to swap the positions of the leading. 2 will take the position of 8, 8 will take the position of 2. And then you change the signs of the non-leading. 1 becomes -1, and 6 becomes -6. And then you simplify the determinant. So for the determinant, we have 2 8s are 16. 16 minus 6 will give us 10. So the inverse is 1 over 10 times 8 minus 6 minus 1, 2. So we have our inverse. Let me just screenshot this. Now, what is step number 3 now? So for step number 3 now, we have our inverse already. Here it is. So we take that inverse and we multiply it to the column matrix, the -1 and 2, with the constants, okay, with the -1 and 2. So let's do that. So here we are multiplying the inverse to the column matrix with the constants. So what you do now, you keep the 1 over 10 still, leave it outside the still, and you're going to multiply row by column, both rows to the same column. So your answer is going to be a column matrix, 2 rows and 1 column. Okay, so I repeat those 2 rows there, 1, 2, applying to 1 column. So you'll end up with 2 rows and 1 column. And how can that be done? That would be 8 times -1 plus -6 times 2. Okay, see that? Row by column. That's how you multiply matrices. So 8 times -1 plus -6 times 2. And we do that with the row below the second row to the same column. So it's -1 times -1, okay, plus the 2 now times 2. So let's simplify this. -8. 8 times -1 is -8. And a -2, 6 times -2 is a +12. So you have a -8 and a +12. So you're going to take out 8 from 12. No, that's a +2. As -6 times +2, sorry. Okay. -6 times +2. That's what I'm saying because I'm looking at 10 there. We should also get multiples of 10 because we have to divide by 10 at the end. So that's a -8 and a -12. -6 times 2 is a -12. -8 and -12, that's -20. Good. But we have to divide by 10. That's going to become -2. X is going to become -2. We have to divide by 10. No. Let's see the denominator. -1 times -1 is a 1. 2 times 2 is 4. 1 plus 4 is 5. Okay, so we're going to get a half. Or y. Y is going to be a half. And now we are going to multiply by 1/10, or we're going to divide by 10. Both the -20 and the 5. We might have to put that in another line. Let me take a screenshot of this because there's an icon there barring the view. So all of this is multiplying by the inverse. We're going to finally divide by 10. So we resume by multiplying -20 and 5 by 1/10. Now multiplying by 1/10 is like dividing by 10. All right, you are not multiplying by 10, you are multiplying by 1/10. So that's like dividing by 10. That's -20 divided by 10 is -2, and 5 divided by 10 is 1/2. So x is equal to -2 and y is equal to a half. And here you have it, an example of how to solve simultaneous linear equations using matrices.